Right now, your heart is beating at a perfectly normal rate. Your muscles are relaxed. You're sitting somewhere safe, probably indoors, almost certainly not being chased by anything. And yet, somewhere deep inside your skull, a tiny ancient alarm system is quietly scanning the room. It has been doing this your entire life. It will never stop. Because your brain, for all its brilliance, has not quite gotten the message that the predators are gone. This is not a metaphor. It is one of the strangest facts about being human. You are walking around with a 3 million-year-old threat detector wired into a brain that also writes poetry, solves equations, and worries about what someone thought of a text message you sent 6 days ago. And those two things, the ancient and the modern, are in constant invisible conflict. To understand why, you need to go back, far back, not to ancient Rome or the pyramids, back to the savannah. Picture this. It is roughly 2 million years ago, somewhere in East Africa. Your ancestor, a small upright creature called Homo habilis, is moving through tall grass at dusk. She weighs about 40 kilograms. She has no claws, no venom, no armor. She cannot outrun a leopard. She cannot outfight a hyena. What she has, her only real weapon, is a brain capable of detecting danger before it arrives. Her survival depends entirely on one thing: not being surprised. So her nervous system evolved to be exquisitely, obsessively tuned to threat. A rustle in the grass, a shadow that moves wrong, a silence that falls a half-second too quickly. Any of these could mean death. And because the cost of missing a real threat was catastrophic, her brain learned to fire first and ask questions later. Better to panic at 1,000 false alarms than to miss a single real one. That brain is the brain inside your head right now. Neuroscientist Joseph Ledoux at New York University spent decades mapping what he called the brain's fear circuitry. He discovered that threat signals travel on two separate pathways. One is fast, bypassing conscious thought entirely, sending an alarm straight to a structure deep in your brain called the amygdala. The other is slower, running through the thinking cortex. The fast path arrives first, always. By the time your rational mind even registers that you heard a loud noise, your body has already flooded with adrenaline, your muscles have tensed, and your focus has narrowed to a pinhole. Ledoux called this the low road, a shortcut that evolution carved into the brain precisely because in dangerous environments there was no time to think. Here is the problem. That shortcut was designed for a world of leopards. It was never updated for a world of email notifications, public speaking, and unanswered phone calls. Psychologist Martin Seligman at the University of Pennsylvania introduced the concept of preparedness. He pointed out that humans are not afraid of all things equally. We are vastly more likely to develop phobias about snakes, spiders, and darkness than about cars or electrical outlets, even though the latter kill far more people today. The reason is that our brains came preloaded with a list of ancestral threats. Things that killed Homo habilis for millions of years. Things that left a fingerprint so deep it became part of the architecture of how we perceive danger. Your brain is still running on that list. Anthropologist Lynn Isbell at UC Davis proposed that the very reason primates developed such sharp visual systems, the ability to detect subtle movement, to read faces, to track things through foliage, was not because of fruit. It was because of snakes. For 60 million years, snakes were the primary predator of our primate ancestors. That relentless pressure, Isbell argued, drove the expansion of the visual cortex. Your ability to see and read the world may have been built, in part, by the snake. That is not a comfortable thought, but it is a revealing one. Because it tells you something important. Your brain was not designed for comfort. It was designed for survival. And survival, for most of human history, meant expecting the worst. So what happens when you take that ancient threat detection machine and drop it into a world with no physical predators? It keeps working. It just finds new things to be afraid of. Neuroscientist Lisa Feldman Barrett at Northeastern University has spent years studying how the brain constructs emotion. Her research shows that the brain is not a passive receiver of the world. It is a prediction machine, constantly modeling what is about to happen based on what has happened before and preloading responses. In an ancestral environment, those predictions were life-saving. A sound in the dark predicted danger. A strange face predicted conflict. A shift in the social group predicted exclusion, which in a small tribe of early humans was effectively a death sentence. In a modern environment, those same prediction circuits are still firing, but the inputs are different. The strange face is now a stranger's photo before a meeting. The shift in the social group is a group chat that goes quiet. The sound in the dark is the vibration of a phone at 3 in the morning. Your amygdala does not know the difference. It receives a signal, matches it to a pattern, and fires an alarm. The alarm does not come with a note explaining that the leopard is actually a performance review, that the silence is just bad cell service. The alarm just fires. This is why, when you stand up to speak in front of a crowd, your hands shake and your mouth goes dry. Those are not signs of weakness. They are the exact same physiological cascade that would have helped your ancestors sprint away from a predator. Increased heart rate, blood redirected to the muscles, attention narrowed to a pinhole. The body preparing for violent, immediate action. You do not need violent, immediate action. You need to give a presentation about quarterly figures. But your biology does not care about quarterly figures. Research by Sapolsky at Stanford, who spent decades studying stress in baboons and humans, showed that the chronic activation of this stress response is one of the most damaging things the modern body experiences. In short bursts, it saves your life. Over weeks, months, years, it corrodes the cardiovascular system, suppresses immune function, disrupts sleep, and accelerates aging. The very system that kept your ancestors alive is quietly damaging the bodies of their descendants because we are running a 2-million-year-old emergency program as a permanent background process. And there is one more layer to this. The brain's threat detection system has a built-in bias researchers call negativity bias. Bad events, bad feedback, bad memories affect the brain roughly 5 times more powerfully than equivalent positive ones. A single harsh criticism echoes longer than 5 compliments. One bad day overshadows a week of good ones. This is not a personality flaw. It is a feature. In a world where missing one threat could kill you, it made evolutionary sense to weight danger far more heavily than safety. The ancestor who dismissed a warning sign did not survive to become your ancestor. Which means pessimism, in a very specific biological sense, may have once been the smartest strategy available. But here is what is remarkable. Here is the part that might actually change how you move through your day. You can know all of this. You can look at your own fear, your own anxiety, your own tendency to catastrophize a text message or lie awake rehearsing a conversation that has not happened yet, and recognize it for what it is. Not a broken mind, not a weak character. An ancient survival system, still doing its job in a world it was never built for. That recognition, that space between the alarm and the response, is where something genuinely new is possible. Feldman Barrett's research suggests that naming an emotion, actually labeling what you feel in language, reduces the amygdala's reactivity. Something as simple as saying, even silently, "I feel afraid because my brain is running a threat pattern right now," interrupts the automatic cascade. It does not eliminate the alarm, but it creates distance from it. It shifts the signal from the low road to the high road, from the ancient reflex to the conscious mind. You will never fully silence the alarm. It is 3 million years old. It is load-bearing architecture. But you can learn to hear it differently. You can learn to say, "There it is again, the old system doing what it was built to do." And then you can ask, slowly, carefully, whether the leopard is real. Most of the time, it is not. And the fact that you can ask that question at all, that you can stand outside your own ancient fear and examine it, is the most extraordinary thing your brain has ever learned to do. Right now, your heart is beating at a perfectly normal rate. Your muscles are relaxed. You are sitting somewhere safe, probably indoors. The predators are gone. And somewhere deep inside your skull, the alarm is still scanning. It always will be. But now at least you know what it is. And knowing, it turns out, changes everything.